Okay, today's lesson is lesson 2. It should be pretty short. This is the separation of variables. And actually, I did a little bit of this in the previous video, but here I'm just going to kind of expand upon it more. So for part A, we're asked to find the general solution. When we are integrating, we have to have like variables together. So your dy's should be with y's, your dx's should be with x's. So if I have dy over dx equals 2x over y, I'm going to kind of cross multiply, right? Kids love cross multiplying. So we have dy is equal to 2x dx, and then I'm going to integrate both sides. So I've got 1/2 y squared is equal to x squared plus c. You only have to add c to one side because the constant isn't really going to matter. A constant just means there's a constant, right? And actually, one moment here. Okay, and we actually could just leave this like this. This is, of course, a perfectly fine solution, but we can manipulate it a little bit. So this is the same as y squared equals 2x squared plus c. Now, I don't need to write 2c because it's the exact same information. And then I can actually just take the square root of both sides. So this is also equal to y is equal to plus or minus the square root of 2x squared plus c, right? So all of this works. All of this is great. I could rewrite this again as like, you know, a negative 2x squared plus y squared equals c. I could write it as 2x squared minus y squared equals c. These are all correct. These all make sense. Okay, let's do another one here. dy over dx is equal to xy. Well, in this situation, I'm going to cross multiply again. I'm going to have to multiply by dx and divide by y. So I'm going to end up with 1 over y dy is equal to x dx. Then I can take the integral of both sides. So 1 over y is going to be the natural log of y is equal to 1/2 x squared plus c. Now I like to add my plus c to my x. You could add it to your y. It doesn't really matter. I don't know. Why bother? So anyway, if I take like this to e power, I can rewrite this as y is equal to e to the 1/2 x squared plus c. And this can actually be written as, if you took e to the c power, then, oh gosh, hold on. Let me think how I'm going to word this. 1 second. Okay, I figured out how I want to say this. So I didn't really write this very well. This is, gross. Not y equals e to the 1/2 x squared space plus c, but y equals e to the 1/2 x squared plus c. Well, this is the same as y equals e to the 1/2 x squared times e to the c, right? But e to the c is just going to be a constant. So I can rewrite that as just c. So my final way to isolate this and really write it is that y equals c e to the, and I'm going to rewrite this as x squared over 2. All right? That's exactly the same thing. Let's do one here, and then we'll do one with the given condition. So 4y prime minus 3 e to the x equals 0. Well, the first thing that I'm going to have to do is rewrite this. So I have 4y prime equals 3 e to the x. And I actually don't like having a y prime because I think it's just, it doesn't work for me. I get it confused. So I'm going to rewrite this with dx, or with dy. So this is going to be 4y dy is equal to 3 e to the x. And if I'm going to take the derivative there, I need to do that, so I'm going to write a dx here. Now, I can take the integral of both sides, so this is going to end up being 2y squared is equal to 3 e to the x plus c. And I can write this as y squared is equal to 3/2 e to the x plus c. So y is equal to plus or minus the square root of 3/2 e to the x plus c. And that's it. That's it. So let's do one more final example. Hopefully you're kind of getting what we're doing here. We want to find the solution of the differential equation that satisfies the given condition. So we are given dy over dx is equal to 1 plus x over xy, and y of 1 is equal to negative 4. So I'm going to rewrite this here. I'm going to have y dy, there's the bell, is equal to 1 plus x over x dx. Okay, so I'm going to rewrite this again as y dy is equal to 1 over x plus 1 dx. I think that'll be easier to integrate. So now I can integrate both sides. So I have 1/2 y squared, oops, I almost wrote dy again, is equal to the natural log of x plus c. Okay, so this is our condition here. We need to actually find c, right? So this is our general solution. This is our general solution. And we are asked to find the particular solution, find the particular, I should have written that there, find the particular solution. So we've got our general. We want to find c if y is when y of 1 is equal to -4. So we're going to have 1/2 times -4, because that's what our y is, right, is equal to the natural log of 1 plus 1 plus c. Okay, so -4 squared is 16 divided by 2 is 8, is equal to the natural log of 1 is 0, is equal to 1 plus c. So if I subtract from both sides, it looks like 7 is equal to c. So my particular solution is that 1/2 y squared is equal to the natural log of x plus 7. And if I want to be a little more specific, which I do, I'd like to write this in slope-intercept form. I'm going to have y squared is equal to 2 ln of x plus 2x plus 14. And so that y is equal to the square root of, I don't know why that says that, but the natural log of x, and I can actually write that as natural log of x squared if I want, plus 2x plus 14, right? Plus or minus there. Okay, hopefully all of that makes sense. If you have any questions, leave them in the comments below. Look forward to seeing you in class and working on this. Okay, bye.